we've been looking at surface area. Remember, it's the area of the outside, so surface area. But now we're going to have pyramids and cones. We used to have prisms and cylinders. Now we're moving into pyramids and cones. You guys might be familiar with those words, what they look like. But if you're not, you will. So, surface area of pyramids and cones. First thing, let's find out. Let's define what a pyramid is. So a pyramid is a solid with a polygonal base and sloping triangular sides that meet in a point at the top. So a pyramid is a solid with a polygonal base and sloping triangular sides that meet in a point at the top. I know we know polygon, so polygonal base means the shape of the base is a polygon. And remember, polygon means the shape that is all straight sides. And remember that you can cut into triangles. That's basically what it is. So the base is a polygon. The sloping triangular sides, what that means is that the sides are triangles, but they're not standing straight, they're standing sideways. So that's why I call it sloping. They're not straight up, they're like slanted. So, and they all meet at a point. Once again, I'm going to show you guys pictures, but don't have to copy the pictures for me to explain them. I have a rectangular pyramid. Notice how the base is a rectangle, and the sides are triangles that meet at one point on the top. I have a hexagonal pyramid, heptagonal pyramid, decagonal pyramid, so on and so forth. So remember, the base is a polygon, and then the top is just a point. I remember I used to cover with you guys prisms. Remember, but prisms had two bases, one at the bottom and one on top. Now pyramids only have one base, and the top is a point. Pyramids that we're familiar with are those in Egypt. Right, you guys have heard of them. The one probably you guys have seen is the one in Vegas. Yeah. Not right now because the glare is not going to help us. I know it's a little warm in here, but but do keep in mind you're only here one period. I'm here the whole day. I know it is hot. So your AC doesn't work? Yeah, my AC doesn't work. So apologies on that one, but there's really nothing I can do. Okay, now going back to this pyramid, you guys might be familiar with. You guys have seen it, the one in Vegas, the Luxor. Yeah. All right. So now, just to remember for prisms and cylinders, I used to make them flat. Hold on just a second. All right, guys. So going back to this, ladies. Going back to this, remember how before I used to make it flat, the prisms and the cylinders? So when I make this flat, I have a rectangular pyramid there. If I make it flat, we should have a base is a rectangle, and then triangles at the side. Right? If I make it flat, have a rectangle and then triangles at the side. If I have a hexagonal pyramid, if I make it flat, I should have a hexagon and triangles at the side. The one that is a little hard to see is a triangular pyramid. But as you guys should imagine, I should have a triangular base and triangles at the side. Do notice though, the amount of the sides, the amount of triangles at the side depends on how many sides the base has. So if the base only has 3 sides, I only have 3 triangles at the side. If the base has 6 sides, I have 6 triangles at the side. We know how to get the area of polygons. Remember, 1/2 times perimeter times bottom. So we know how to get the area of polygons. We know how to get the area of triangles, and we know how to get area of rectangles. And then on the sides, I have triangles only, so we should be good. Now let's copy this thing up. The surface area of a pyramid, is the sum of the base and the triangular sides. Right, the base varies, so that's what I'm just going to call it base. The surface area of a pyramid is the sum of the base and the triangular sides. diagonal pyramid, get the area of the hexagon, get the area of the triangles at the side, and then just add them all, as you expected. So the surface area of a pyramid is the sum of base and the triangular sides. Makes sense, right? Can I take this off? Alright, so now let's talk about a cone. A cone is a solid with a circular base that tapers to a point. Tapers means that it vanishes or it gets to a point. You guys should be familiar with the guys. Mainly, you should be familiar with tapers. When you guys go to the barber, they do some taping. Your hair's fading, so it fades to a point. So a cone is a solid with a circular base that tapers to a point. So remember, pyramid, the base is polygonal, so straight only. Cone, the base is circular. That's the only difference. Can I take this off? No. Yeah? Okay, so just to explain it, I have a circle and everything vanishes to a point. If I make it flat, my figure looks like this, right? The base at the bottom, you can imagine the circle, but then the sides, it's transformed into that weird looking shape, like a pizza slice. It's not a triangle, because the bottom is not straight, so it's not a triangle. And based on sector area, we came out with a formula. I know I had tried to avoid formulas, but this one I have to give you guys a formula for that slice. So we know the formula for a circle, right? Radius squared pi. Now for this one, let's do this. Do me a favor, copy this out. Copy this cone. You're going to have a radius of the circle. You're going to have an h for the height. That's in the center of the cone. You're going to have a radius for the circle. You're going to have a height for the cone. We're not going to quite use the h today, but we will use it in a few weeks. And then this little side is L for lateral height, the height of the side. Do keep in mind my L is a little slanted, right? It's not straight. The lateral height is a little slanted. So once again, I have R for radius, I have H for the height of the cone, and L is for the lateral height. So my lateral height is a little slanted. And then the formula will be surface area of the cone is radius squared pi plus radius times L times pi. Once again, the surface area of a cone is the area of a circle, radius squared pi. So the area of a circle plus the lateral is going to be radius times L times pi. Right? Radius times the slanted height times pi. Once again, the h, I'm not using it today. We're going to use it in a few weeks. Can I take this off? No. So make sure for the lateral side, I'm going radius times L times pi. Right? R squared pi, you know, it's the formula for area of a circle. So it's a circle plus radius times slanted height times pi. Okay? All right, let's take a look at our work. So let's take a look at our worksheet, question number 1. The instructions said find the surface area of each figure, round your answer to the nearest hundredth. Remember, hundredth means 2 decimal places. So 2 decimal places. Leave your answers in terms of pi for answers that contain pi. So circles or cones would have a pi. Okay, let's take a look. Question number 1. It looks like the base is a hexagon. So let me draw the best I can. Let me draw my hexagon. And I know for each of my sides, I'm going to have a triangle. So I made my pyramid flat. And I made the pyramid flat. Again, in math, we call that net. It's a net. But it's flat. We know how to get the area of a polygon. I'm going to go, in this case, I'm going to go 1/2 times 42 times 6.1. Remember, 1/2 times perimeter times apothem. Are you all good where I got my numbers from? The perimeter. Right, each side is 7, there's 6 of those. So add all the sides. Okay. And the apothem is 6.1, so we're good where I got my numbers from? So 128.1? Alright, so the what is it?
42?
Yes. The perimeter. Okay, see how each side is 7? There's 6 of them. Add them all.
Okay.
Yeah? Okay. Alright guys, so looking at this, so the area of the base is 128.1. The base. Now let's look at the triangles. If you look at one triangle, the numbers across the 90 degrees are 7 and 12.6. Right? The two numbers across for a triangle are 7 and 12.6. So the way I want to do this, I'm going to go 1/2 times 7 times 12.6. Remember, for a triangle, I go 1/2 times the two numbers across the 90 degrees. So, what is it? 44.1. Okay, so each triangle is 44.1. You can just come over 44.1 for each. Now just add everything. To help us with the triangle, instead of going 44.1 plus 44.1 plus 44.1 plus 44, just go 44.1 times 6. Right, that's basically it. So 44.1 times 6, that's how you add them all, plus 128.1. So you should have 392.7. And that's it. 392.7. So surface area of a pyramid is the area of the base, the area of the triangles, just add them up. Let's take a look at number 2. I told you guys that hard pictures, the hard ones to see, will be triangular pyramids. For you, because it's hard to see which one is the base. For you guys to know which one is the base, I'm gonna give you guys the measurements of all the sides of the base. So in my case, my base will be that triangle. So for you to know which one is the base, I give you the measurements for each of the 3 sides of that base. If you notice the other triangles, I don't give you all the sides. So we know the base is a triangle, and we know there's a triangle on each side. I know for area of triangles, I have to go 1/2 times the two numbers across the 90 degrees. In the base, the two numbers across the 90 degrees are 5 and 4.3. So I have to go 1/2 times 5 times 4.3. And you should have 10.75. And again, for the triangle, we go 1/2 times the two numbers across the 90 degrees. Now for the sides, the two numbers across the 90 degrees are 5 and 8.1. So So I'm going to go 1 half times 5 times 8.1. 20.25. So each triangle is 20.25. So each triangle came 20.25. Now add everything. And I'm going to get 71.5. That makes sense? Once again, to help you guys a little, the one base that is hard to see is a triangular base. So for you to know which one is the base, I'm giving you guys the measurements of the 3 sides. That way you know which one is the base. Now let me skip a few questions. Let me take a look at question number 9. And the reason why I'm going to do number 9, because on rectangular pyramids, not all my triangles are the same. So that's why I'm going to look at number 9. I know the base is a rectangle, and then I have 4 triangles. The base for the rectangle, I get 77. Right, I multiply the 2 numbers across at 90 degrees. There's no half because it's a rectangle. So for the rectangle, I got 77, right? 7 times 11. Now for my triangles, for 2 of my triangles, the numbers that cross at 90 degrees are 11 and 10.6. And those are the 2 numbers that cross at 90 degrees. So I have to go 1 half times 11 times 10.6, and that's only going to be for 2 triangles. So 2 of them is 58.3. So 2 triangles is 58.3. Right, the ones on the front and the ones on the back. Only those 2. Now the other 2 triangles, the way the 2 numbers across 90 degrees are 7 and 11.4. So for those, I have to go 1 half times 7 times 11.4. So I get 39.9. On rectangular pyramids, not all the triangles are the same. If it's a square pyramid, yes, they are all the same. But rectangular, non-squared, then they're not. Add everything, and you should get 273.4. Yes? Easy? Huh? Alright. Can I take this off? Okay. Let me take a look at number 10, just because I haven't covered a code. Let me take a look at number 10. Remember that breakdown, it looks like a slice of a pizza and a circle. The 14 is my diameter. I need the radius, so I'm going to say the radius itself. Right, because the radius is only half. Some of your circles, I will give you guys the diameter, some of them I'll give you guys the radius. You need the radius. So since the radius is 7, I'm going to say the area of the circle is 49 pi. Right, radius squared. So 49 pi for the circle. For the other part, I'm going to multiply radius times 15.7 pi. So let me go 7 times 15.7. I get 109.9. So I'm going to call this 109.9 pi. Remember, it is radius times lateral height pi. Then just add everything. $158.9 pi. Right, cones are a little bit easier. But for cones, you do need the formula. Right? That one, there's no way around it. Alright, any questions? No questions?